We're going to review the method of solving systems using elimination today. The first thing that I want you to do is number the problems 1 through 10. Follow my lead. I'm going across. I'm going to do a few of them with you, and then I'm going to leave you on your own to try some more, and then we'll go back over them together. I've got them numbered to number 10. You guys know I write real large. I'm going to give myself some sections to work in here. There we go. Now, in order to use the elimination method, the object of the game is that we try to identify variables. I'm going to actually focus on number 3 first, and there's a reason why. In number 3, I'm going to get at the big idea of if I go and combine these two systems down, when I have 7x minus 7x, those are going to go away. They're going to be eliminated. I just eliminated the x's because the 7 and the negative 7 are opposites. And then I'm going to combine down. I have minus 1y plus 5 more y's. So that's going to give me a 4y equals, and I have negative 10 minus 6. It's like you owe me $10 and you borrow another 6, so I'm going to have negative 16 there. I'm going to move on and solve for y by dividing both sides of this equation by 4. And I'm going to find out then that y is equal to negative 4. Now, if y is equal to negative 4, I'm going to go back in, and I'm actually going to plug in my y into the first equation. Minus negative 4 equals negative 10. 7x minus negative 4. That's actually going to give me 7x plus 4 equals negative 10. If I subtract 4 from both sides for undoing, I get 7x equals negative 14. If I divide both sides by 7, I'm going to wind up with x equals negative 2. So the solution to this system is negative 2, comma, negative 4. I eliminated x, solved for y, then used my y to find the x. Now, not all of them are going to be as straightforward as number 3 was, where we can see the opposite of 7 and negative 7 like we did there. In number 1, I see that I've got 3x and 3x, but they're both positive. If I combine those, it's going to give me 6. And then the coefficients of y are 2 and 4, so I don't have any access to opposites there. But what I can do is change this equation so that 3 is actually a negative 3, and I do that by multiplying every part of the equation by negative 1. I am thinking ahead and going, what number can I multiply 3x by to make it negative 3x? That's why I chose negative 1. So I'm going to come over here and I'm going to rewrite an equivalent system. This whole system can be rewritten as 3x plus 2y. I'm just rewriting the top equation. I didn't do anything to change that. And the second equation would be negative 3x minus 4y, and that equals negative 1. Now, when I go through the same method I did in 3 and I start combining down, my x's are going to turn into 0. 2x minus 4y is going to give me negative 2y. Negative 13 minus 1 is going to give me negative 14. I'm going to finish solving for y by dividing by negative 2 on both sides and find out that y is 7. Now I'm going to go back and use y is 7. I'm going to throw that into the first equation. 3x plus 2 times negative 7 equals negative 13. So, it's not negative 7, it's positive. 3x plus 2 times 7 equals 13. 2 times 7 is 14. When I undo 14, I'm going to subtract it from both sides. I'm going to wind up finding out that 3x is equal to negative 27. To finish this, I'm going to divide both sides by 3. What I get then is x is negative 9. So the solution to this system is negative 9, comma, 7. I eliminated the x's in this case, solved for y, and then went back and used it. Number 2 is very similar. Number 2, if I look at what I have, the coefficients of x's aren't opposites. The coefficients of y's aren't opposites, but I can get to opposites pretty easily with the coefficients of y. So I'm going to multiply both sides of this equation by negative 1. And I'm going to rewrite this system. 3x plus 7y equals 14. And negative 2x minus 7y equals negative 21. When I combine down, the y's go away. 3x minus 2x gives me just x. Fantastic. 14 minus 21 is going to leave me with a negative 7. So single step in solving for x. And now I'm going to go use my x. 3, I'm going to plug it into the first equation. 3 times negative 7 plus 7y equals 14. 3 times negative 7 is negative 21, plus 7y equals 14. I'm going to, add 21 to both sides of the equation to undo that. And I'm going to wind up with 7y equals 35. When I divide both sides of the equation by 7, I get y is equal to 5. So the solution to number 2 is negative 7, 5. I'm going to stop the video at this point and let you go ahead and try on your own, and then I'll restart it with the rest of the responses. Number 4. In number 4, I have opposite coefficients on x. I'm going to combine down and find out that 9y minus 7y is going to give me 2y. Negative 19 equals 13 is going to give me negative 6. When I divide both sides by 2, I wind up with y is equal to negative 3. I'm going to go in and use that negative 3 in the first equation. 4x plus 9 times negative 3 equals negative 19. And I'm going to go through the process of solving for x. 4x minus 27 equals negative 19. I'm going to add 27 to both sides. 4x equals negative 19 plus 27 is 8. I'm going to wind up with x equals 2. My solution here then is 2, negative 3. Make sure your solutions are large and easy to find. Number 5. In number 5, I notice that I have opposite coefficients on the y. I can eliminate the y's. 2x minus x is going to give me an x. Negative 12 plus 18 is going to give me a positive 6. Easy squeezy. X is 6. I'm going to use that x in the first equation. 2 times 6 plus 3y equals negative 12. 12 plus 3y equals negative 12. If I subtract 12 from both sides, I'm going to wind up with 3y equals negative 24. Divide by 3 on both sides. Y is going to be negative 8. My ordered pair solution, 6, negative 8. Make sure it's circled in large. Number 6. In problem 6, I don't have opposite coefficients, but what I do see is that I've got a positive 2y and on both, I can multiply my second equation by negative 1 like I've done on some of the others. Multiply by negative 1 on this side. Rewrite my system, negative 3x plus 2y equals 23. Negative 5x minus 2y equals 17. When I combine down, my y's go away. Negative 8x equals 40. When I divide by negative 8, I get x equals negative 5. If x is equal to negative 5, I'm going to use it, plug it in, and solve for y. 15 plus 2y equals 23. If I subtract 15 from both sides, I'm going to get 2y equals 8. And if I divide by 2, I'm going to get y equals 4. Notice I just skipped some steps, but I talked about them. So I've got a solution of negative 5, 4. Moving on to number 7. I have opposite coefficients on my y's. I'm going to combine down. Negative 2x equals negative 6. I'm going to divide by negative 2 on both sides and find out that x is equal to 3. When I use x is equal to 3 to solve for y, 21 minus 5y equals negative 24. If I subtract 21 from both sides, negative 5y equals negative 45. If I divide by negative 5, y must be 9. 3, 9 is the ordered pair solution for this problem. In number 8, I see the same coefficients on y. I'm going to multiply the second equation by negative 1 on both sides. When I do that, 4x minus 7y equals 5. And negative 9x plus 7y equals 15. Combine down, 4x minus 9x is going to give me negative 5x. The negative 7 and the positive 7y make the y's go away. Negative 5x equals 20. Negative 5 on both sides divide by. X is negative 4. I'm going to use negative 4. 4 times negative 4 minus 7 times y equals 5. Negative 16 minus 7y equals 5. If I add 16 to both sides, negative 7y equals 21. If I divide both sides by negative 7, I'm going to get y equals 3. I'm sorry, y equals negative 3. Solution to this one, negative 4, negative 3. I will post the remaining work on these if need be, but I'm going to give you the last solutions. X is 5 and Y is -7 in number 9. And if you're doing your math right on number 10, X is -7 and Y is -3. Hope this helps.